Look up at the night sky for a moment. Thousands of stars shimmer across the darkness, each one a blazing sun burning millions of kilometers away. Some are young, some are ancient, and many were already shining long before Earth even existed. But here's the strange part. The universe didn't have to create them at all. In the beginning, the cosmos was filled mostly with simple gas, thin clouds of hydrogen drifting through vast emptiness. Nothing about that early universe guaranteed the existence of stars, planets, or life. So why did those quiet clouds ever collapse and ignite into brilliant stellar furnaces? Why didn't the universe remain dark forever? In this journey across cosmic scales, we'll explore one of the deepest questions in astronomy, from tiny atomic motions inside gas clouds, to colossal nebulae spanning light years, to the birth of our own sun and the stars that lit up the first galaxies. Because hidden inside those glowing points of light is a profound story, a story about gravity, energy, and the strange tendency of the universe to turn simple matter into extraordinary structures. And by the end of this journey, we may begin to understand something remarkable: why the universe chose to create stars at all. Across the silent depths of space, enormous clouds of gas drift slowly through the darkness. They are cold, thin, and almost invisible, stretching across light years of empty space. Yet inside some of these quiet clouds, something extraordinary eventually happens. Suddenly, after millions of years, a brilliant star ignites. From afar, it almost looks like a cosmic miracle. A dark cloud slowly brightens until a new sun appears, blazing with light and energy. But the universe rarely relies on miracles. There are always hidden processes at work. And here lies one of the deepest questions in cosmic science. Why do stars form at all? Why does matter gather together instead of remaining scattered forever in space? After all, the universe is unimaginably vast and mostly empty. One might expect gas to simply drift endlessly through the darkness. Yet the cosmos seems to prefer structure over chaos. Instead of remaining diffuse, clouds of gas slowly condense and ignite. It's almost as if the universe has a tendency to build things: stars, planets, galaxies. But what invisible force pushes matter to come together in the first place? Understanding this mystery means looking far beyond a single star. Astronomers have discovered that stellar birth is happening everywhere. Across the universe, entire regions glow with the light of newborn stars, and these places reveal that star formation is not rare. It's a cosmic pattern waiting to be explored. When astronomers turn their telescopes toward the deepest regions of space, they begin to notice something remarkable. The universe is not quiet or static. It's alive with regions where new stars are constantly being born. These places glow with color and energy, like cosmic nurseries hidden inside vast clouds of gas and dust. And once scientists started looking closely, they realized these stellar birthplaces are everywhere. One of the most famous examples floats within our own galaxy. Enormous nebulae, towering clouds of gas stretching across dozens of light years, shine with a soft, luminous glow. Inside them, powerful newborn stars illuminate the surrounding material like lanterns inside a fog. What once seemed like empty darkness suddenly becomes a cradle of creation. These stellar nurseries can be unimaginably large. Some are so vast that thousands of stars may be forming within them at the same time. It's a bit like watching sparks ignite across a giant cosmic storm cloud. Each spark marks the birth of a brand new star beginning its life. Infrared telescopes reveal even more astonishing details. While ordinary light is blocked by thick cosmic dust, infrared instruments can peer straight through it. Behind those dusty curtains, astronomers see clusters of embryonic stars slowly emerging. Some are only a few 100,000 years old, practically newborns on a cosmic timeline. All of this reveals something profound about the universe. Star formation isn't some rare accident happening once in a while. It's an ongoing process woven into the fabric of galaxies themselves. But to understand why these stars appear, scientists must zoom in much deeper, down to the smallest ingredients of matter itself. To truly understand how stars are born, the journey must zoom in, far beyond clouds and nebulae. Inside those vast regions of gas are trillions upon trillions of tiny particles. Most of them are simple hydrogen atoms, the smallest and most abundant building blocks in the universe, and each one drifts quietly through the cold emptiness of interstellar space. At first glance, these atoms seem far too scattered to ever form something as massive as a star. The distances between them can be enormous compared to their tiny size. Imagine a handful of dust grains floating inside a gigantic cathedral. That's roughly how sparse these cosmic gas clouds can be. But space is never perfectly uniform. Even in a seemingly smooth cloud, tiny fluctuations begin to appear. In some regions, just a few extra atoms gather closer together. The difference is incredibly small, almost insignificant at first. Yet those microscopic imbalances slowly begin to matter. Where slightly more atoms gather, gravity becomes just a little stronger. And that extra pull attracts even more nearby particles toward the same region. It's a quiet process, almost like snowflakes gradually accumulating on a hillside. Over millions of years, these tiny differences grow larger and larger. Small pockets of gas slowly become denser than their surroundings. What started as a barely noticeable imbalance begins a long chain reaction, and soon, gravity starts pulling entire regions of the cloud inward. To understand what happens next, it helps to look at something closer to home. Gravity pulling matter together is not unique to stars. It's happening all around the universe. Planets, moons, and even asteroids exist because gravity gathers material into larger objects. The same cosmic rule that builds worlds also shapes the birth of stars. Imagine dust slowly clumping together in space. Tiny grains collide and stick, forming slightly larger pieces. Over time, those pieces grow into rocks, then mountains of rock, and eventually entire planets. It's a bit like rolling a snowball down a hill. It gathers more snow the farther it goes. In our solar system, this process created worlds like Earth, Mars, and Jupiter. Gravity pulled billions of pieces of debris into spheres of rock and gas. Day after day, year after year, the pull never stopped working. It's the same invisible force that keeps the moon orbiting Earth today. Now imagine that process scaled up dramatically. Instead of rocks and dust gathering into planets, entire clouds of gas begin collapsing together. The mass involved isn't the size of a planet anymore. It's hundreds of thousands of times larger. Gravity begins drawing enormous amounts of material toward a single center. As more gas gathers, the growing mass strengthens gravity even further. The collapse accelerates, pulling in surrounding material, like water spiraling into a whirlpool. What began as a slight imbalance in a thin cloud is now becoming a powerful gravitational funnel. And deep inside that collapsing cloud, something extraordinary is about to happen. For a long time, the birth of stars remained hidden from human eyes. Stellar nurseries are filled with thick clouds of cosmic dust that block visible light. To ordinary telescopes, these regions look like dark patches against glowing nebulae. It's as if nature placed a curtain over the universe's most dramatic events. But modern astronomy has found clever ways to peek behind that curtain. Infrared telescopes can detect heat instead of visible light, and heat waves pass easily through the dust that normally hides these regions. Suddenly, places that once looked empty begin revealing extraordinary activity. Inside those dusty clouds, astronomers observe glowing knots of collapsing gas. These are protostars, young stars still forming deep inside their birth clouds. They shine faintly at first, wrapped in swirling envelopes of gas and dust. It's a bit like watching a campfire slowly ignite inside a thick fog. Powerful observatories such as space-based telescopes can see thousands of these objects at once. Clusters of infant stars appear embedded within enormous molecular clouds. Some of them launch narrow jets of gas that shoot outward for light years. These jets act like cosmic signposts, revealing where new stars are growing. By studying these stellar nurseries, scientists can watch star formation almost in real time. They measure temperatures, gas motion, and the slow collapse of entire regions of space. Piece by piece, these observations reveal how gravity begins transforming clouds into stars. But to truly understand the moment a star ignites, we must explore the physics driving this collapse. At the heart of star formation lies a quiet but powerful competition. On one side, gravity pulls gas inward, trying to squeeze the cloud tighter and tighter. On the other side, pressure from the gas itself pushes outward, resisting that collapse. For millions of years, these two forces struggle for control. Gas may look calm from afar, but its particles are constantly moving. Atoms bounce, collide, and spread energy in all directions. This motion creates pressure, a force that tries to keep the cloud expanded. It's similar to air inside a balloon pushing against the rubber walls. Gravity, however, never rests. Every particle of gas attracts every other particle, no matter how far apart they are. Slowly and steadily, That attraction begins drawing the cloud inward. The more material gathers, the stronger the pull becomes. As the cloud collapses, something fascinating happens. The gas becomes compressed, and compression causes temperature to rise. It's similar to how bicycle pumps become warm when air is squeezed inside. In space, the same principle works, but on a colossal scale. Eventually, the temperature at the center climbs to millions of degrees. At that moment, atomic nuclei begin to collide and fuse together. Hydrogen atoms combine to form helium, releasing enormous energy. And with that explosive ignition, a new star finally begins to shine. Around 4.6 billion years ago, our own cosmic neighborhood looked very different. There was no sun, no Earth, and no planets circling through space. Instead, the region that would become our solar system was just a vast cloud of gas and dust, quiet, cold, and slowly drifting through one corner of the Milky Way galaxy. Then something disturbed that cloud. Perhaps a nearby supernova explosion sent shockwaves through space, or maybe the cloud simply became dense enough for gravity to take control. Either way, the enormous cloud began collapsing inward. As gravity pulled material toward the center, the cloud started spinning faster. The same thing happens when an ice skater pulls their arms inward during a spin. The rotation tightens, speeds up, and flattens the collapsing cloud into a disk. At the center of that spinning disk, the young sun began to form. Meanwhile, the surrounding disk of gas and dust became a busy construction zone. Tiny particles collided, stuck together, and slowly built larger and larger objects. Over millions of years, these clumps grew into asteroids, moons, and planets. Step by step, the architecture of our solar system emerged from the chaos. At the center, the sun finally ignited with nuclear fusion. Its light flooded the young solar system for the first time. The remaining gas was blown outward by powerful solar winds. And within that newborn system of planets, one small world would eventually become home to life. When we look at the sun rising each morning, it's easy to forget what it truly represents. That glowing disk in the sky is not just a source of daylight. It is the direct result of the same cosmic process that forms stars across the universe. Without that process, Earth, and everything on it, would never have existed. Stars are the universe's great element factories. Inside their blazing cores, nuclear fusion transforms simple hydrogen into heavier elements. Over millions or billions of years, stars forge carbon, oxygen, nitrogen, and iron. These are the very ingredients that later become planets, oceans, and living cells. When massive stars reach the end of their lives, they explode in colossal supernovae. Those explosions scatter newly created elements across space like cosmic seeds. Clouds of enriched gas then drift through galaxies. Eventually, they gather again to form new stars and planetary systems. Our own solar system was born from such recycled material. The iron in Earth's core, the oxygen in the air, and the calcium in human bones were all created inside ancient stars. In a very real sense, every atom in our bodies was forged in stellar furnaces. We are quite literally made of stardust. And yet, stars do more than create matter. They provide energy. The sun's light drives weather, fuels plant growth, and powers entire ecosystems. Every breath of oxygen and every drop of food energy ultimately traces back to sunlight. But while stars shape life on individual planets, their influence extends far beyond, into the structure of entire galaxies. Now the perspective expands far beyond a single star or planetary system. Entire galaxies are filled with enormous regions where stars are continuously forming. These stellar nurseries are scattered across spiral arms like glowing islands in a cosmic ocean, each one quietly building the next generation of stars. In spiral galaxies like the Milky Way, star formation often occurs along sweeping spiral arms. These arms act like traffic lanes for gas and dust moving through the galaxy. As clouds enter these crowded regions, they begin to compress. That compression can trigger the gravitational collapse that leads to new stars. Some galaxies are calm and slow in their star production. Others, known as starburst galaxies, form stars at astonishing speeds. In these places, thousands of stars may ignite in a relatively short cosmic moment. It's almost like watching fireworks explode across an entire galaxy. The rate at which stars form dramatically shapes a galaxy's future. Young, active galaxies glow with brilliant blue light from hot newborn stars. Older galaxies, where star formation has slowed, appear redder and quieter. Their brightest stellar generations have long since faded, so star formation is not just about individual stars appearing in space. It's a process that determines how galaxies grow, shine, and evolve over billions of years. Yet to understand why the universe contains stars at all, we must travel back even further, back to a time when the very first stars were about to light up the cosmos. To truly understand why stars exist, the journey must go all the way back to the beginning of the universe. Roughly 13.8 billion years ago, the cosmos began with the Big Bang. In its earliest moments, the universe was unimaginably hot and dense. There were no stars, no planets, only a glowing sea of energy and particles. As the universe expanded, it gradually cooled. Within the first few minutes, the simplest atomic nuclei formed, mostly hydrogen and helium. For hundreds of thousands of years, matter and light were trapped in a dense cosmic fog. The universe was bright, but it had no structure yet. Eventually, the first atoms formed and the universe became transparent. Gravity then began its slow work, pulling slightly denser regions of gas together. Tiny fluctuations left over from the early universe started growing larger. These small differences would eventually shape the large-scale structure of the cosmos. Over millions of years, vast clouds of hydrogen collapsed into the first stars. These early stars were very different from those we see today. They were massive, extremely hot, and lived short but dramatic lives. When they exploded, they began enriching the universe with heavier elements. Those first stellar generations changed the universe forever. They lit up the darkness, ending the cosmic dark ages. They created the elements needed for planets, oceans, and life. And their formation marked the beginning of an endless cycle of cosmic creation that continues even now. On a clear night, the sky above Earth fills with countless points of light. Each of those distant stars began its life inside a cold cloud of gas. What once drifted silently through space eventually ignited into something brilliant, a transformation that has repeated itself across the universe for billions of years. This process is not rare or accidental. It is part of a vast cosmic cycle that constantly reshapes the universe. Gas clouds collapse, stars ignite, elements are forged, and new systems are born. Over time, the universe turns simple matter into astonishing complexity. Every star we see is a chapter in that story. Some stars will live quietly for billions of years. Others will explode and scatter their material across space. And from that scattered material, entirely new stars and planets will emerge. Somewhere in those newly formed systems, worlds may appear. On some of those worlds, oceans might form, and life might begin. Eventually, living beings could look up at their night sky and wonder how those distant stars came into existence. In a way, the universe is constantly creating the conditions to understand itself. From drifting atoms to blazing stars, the same physical laws guide everything. Matter gathers, ignites, evolves, and eventually forms minds capable of asking questions. And the mystery of starbirth becomes part of humanity's endless search to understand the cosmos.